Whatever discipline we're in, I think it's always good to learn from the giants, the greats, those that have already done the hard things. And instead of inventing the wheel, we can learn from that, copy that, and then from there we can further extend it. And one of the giants is, of course, Spotify. Millions of users, millions of streams per day. How do they deal with all the data that's flowing in? This is exactly what this article is talking about. Title: How Spotify built its data platforms to understand 1.4 trillion data points. And if I understand it correctly, it's 1.4 trillion data points per day. It's an article written by ByteByteGo on blog.bytebytego.com. And for those of you that don't know me, my name is Pascal. I have a PhD in mathematics. I used to work as a data scientist. Then I fell in love with software engineering. Now I'm doing a master's in software engineering. And on this channel, we share all these articles daily that is to do with software engineering, development, or anything closely related to that, even productivity. So if you're interested in that kind of content, make sure to like and subscribe. Disclaimer: the details in this post have been derived from the details shared online by the Spotify engineering team. All credit for the technical details goes to the Spotify engineering team. The links to the original articles and sources are present in the references section at the end of the post. We've attempted to analyze the details and provide our input about them. If you find any inaccuracies or omissions, please leave a comment and we'll do our best to fix them. Every day, Spotify processes around 1.4 trillion data points. These data points come from millions of users around the world listening to music, creating playlists, and interacting with the app in different ways. Handling this volume of information is not something a few ad hoc systems can manage. It requires a robust, well-designed data platform that can reliably collect, process, and make sense of all this information. From payments to personalized recommendations to product experiments, almost every decision Spotify makes depends on data. This makes its data platform one of the most critical parts of the company's overall technology stack. I would say these days, this is probably the case for most companies. I think these days, lack of data, yes, but also what's more important is we have abundance of data. How do we manage them? How do we use them is a bigger question. Spotify did not build this platform overnight. In the early years, data systems were more improvised. As the company grew, the number of users increased and the complexity of business decisions became greater. Different teams began collecting data for their own needs. Over time, this led to a growing need for a centralized, structured, and productized platform that could support the entire company, not just individual teams. The shift towards a formal data platform was driven by both business and technical factors. Business drivers. Spotify needed high-quality, reliable data to support its core functions, such as financial reporting, advertising, product experimentation, and personalized recommendations. Data had to be consistent and trustworthy so that teams could make important decisions with confidence. Technical drivers. The sheer scale of the data meant the company needed strong infrastructure that could collect events from millions of devices, process them quickly, and make them available in usable form. It also required clear data ownership, easy searchability, built-in quality checks, and compliance with privacy regulations. This evolution happened organically as Spotify's products matured. With each new feature and business need, new data requirements emerged. Over time, this learning process shaped a platform that now supports everything from real-time streaming analytics to large-scale experimentation and machine learning applications. I can see why Spotify would try to hire world-class data engineers, data scientists, and software engineers. Like this is such a difficult problem, I feel like. In this article, we'll look at how Spotify built its data platform and the challenges it faced along the way. Spotify data platform on a high level. So 1.4 trillion data points per day. We have the data platform, and then data platform transforms this data points to usable data sets for user personalization, experimentation, and so on. So this is a sponsored post, we'll skip that. Platform composition and evolution. In its early years, Spotify's data operations were run by a single team. At one point, this team was managing Europe's largest Hadoop cluster. So it's run by a single team. Okay, for reference, Hadoop is an open source framework used to store and process very large amounts of data across many computers. At this stage, most data work was still centralized, and many processes were built manually or handled through shared infrastructure. As Spotify grew, this model became too limited. The company needed more specialized tools and teams to handle the increasing scale and complexity. Over time, Spotify moved from that single Hadoop cluster to a multi-product data platform team. This new structure allowed them to separate the platform into clear functional areas, each responsible for a specific part of the data journey. At the core of Spotify's platform are three main building blocks that work together: data collection. This part of the platform focuses on how data is gathered from millions of clients around the world. These clients include mobile apps, desktop apps, web browsers, backend services. Every time a user plays a song, skips a track, adjusts the volume, or interacts with the app, an event is recorded. Spotify uses specialized tools and event delivery systems to collect these events in real time. This ensures that the data entering the platform is structured, consistent, and ready to be processed further. Data processing. Once data is collected, it must be cleaned, transformed, and organized so it can be used effectively. This happens through data pipelines, which are automated workflows that process large amounts of information on a fixed schedule or in real time. These pipelines might do things like aggregating how many times a track was played in a day, linking a user's activity to recommended systems, or preparing data for financial reports. By scheduling and running thousands of pipelines, Spotify can provide up-to-date, accurate data to every team that needs it. A bit of a lore here is that I used to work as a data engineer, and I loved it. It was really fun job. Like, this is exactly what data engineers do, and it's very challenging, but also it's very rewarding too, and it's fun. I like being on the background a bit and doing all these things on the background so that it's ready for the data analysts to take it away and use, for data scientists to take it away and use. Data management. This part ensures that the data is secure, private, and trustworthy. It includes data attribution, privacy controls, and security mechanisms to comply with regulations and internal governance rules. Data management also deals with data integrity, which means making sure the data is correct, consistent, and not corrupted during collection or processing. These three areas are not isolated. They are deeply interconnected, forming a platform that is reliable, searchable, and easy to build on. See the diagram below that shows the key components of the data platform. So someone plays music, the event gets delivered to the data platform, data management and interoperability is processed, and before getting into its usage. For example, once data is collected and processed, it becomes searchable and can be used directly in our other systems. One of the most important systems it powers is Spotify's experimentation platform called Confidence. This platform allows teams to run A/B tests and other experiments at scale, ensuring new product features are backed by real data before being fully launched. I wonder how this architecture is different to other apps. Like, I'm thinking Uber or any other big apps like that. I imagine it to be, until now, I feel like it's quite similar for a lot of apps. Data collection, event delivery at scale. One of the most impressive parts of Spotify's data platforms is its data collection system. Every time a user interacts with the app, whether by hitting play, searching for a song, skipping a track, or creating a playlist, an event is generated. Spotify's data collection system is responsible for capturing and delivering all of these events reliably and at a massive scale. Spotify collects more than 1 trillion events every day. This is an extraordinary amount of data flowing in constantly from mobile apps, desktop clients, web players, and other connected devices. To handle this, the architecture of the data collection system has evolved through multiple iterations over the years. Early versions were much simpler, but as the user base and product features expanded, the system had to be redesigned and keep up with growing scale and complexity. I wonder how it looked like at the start and how it looks like now. That would be really cool to see. How developers work with event data. At Spotify, product teams don't need to build custom infrastructure to collect events. Instead, they use client SDK that makes it easy to define what events should be collected. Here's how the workflow works. A team defines a new event schema, which describes what kind of data will be collected and in what format. For example, a schema might specify that each play event should include the user ID or an anonymous identifier, the song ID, the timestamp, and the device type. Once the schema is defined, the platform automatically deploys all the infrastructure needed to handle that event. This includes pub, sub, queues to reliably stream data as it arrives, anonymization pipelines to remove or protect sensitive user information, streaming jobs to process and route the data further down the platform. If a schema changes, for example, if a team adds a new field like playlist ID, the system automatically redeploys the affected components so the infrastructure stays in sync. This would be really hard to set up, I feel like. There would be a big complexity in setting this up. And I think this is the software engineering working with some data engineers setting this up. And yeah, but if this works, it would be worth it. It would just increase the productivity by so much. But also it feels like it could be quite dangerous, because if you add a field, the system automatically redeploys the affected components so the infrastructure stays in sync. Maybe there's an option to refill the existing data, maybe there isn't. Yeah, but this sounds like a really awesome thing to have. See the diagram below. Datasets are encrypted with access control and retention set as part of our compliance strategy. Event receivers, pub-sub queues, clean and transform, GDPR, data protection, anonymization, cloud storage that goes to consumption dataset. This level of automation is made possible through Kubernetes operators. Okay, Kubernetes operators. An operator is a special kind of software that manages complex applications running on Kubernetes. Kubernetes is something that manages a group of containers, which is the container orchestration, yeah, that's the right word. Container orchestration system Spotify uses to run its services. In its simple terms, operators allow Spotify to treat data infrastructure as code, so changes are applied quickly and reliably without manual work. Built-in privacy and security. Handling user data at this scale comes with serious privacy responsibilities. Spotify builds anonymization directly into its pipelines to ensure that sensitive information is protected before it ever reaches downstream systems. They also use internal key handling systems, which help to control how and when certain pieces of data can be accessed or decrypted. This is essential for compliance with privacy regulations like GDPR and for maintaining user trust. Centralization and self-services. A key strength of Spotify's data collection system is its ownership model. Instead of making the central infrastructure team responsible for every change, Spotify has designed the platform so that product teams can manage most of their own event data. This means the team can add or modify event schemas, deploy event pipelines, make small adjustments to how their data is processed. They can do all this without depending on the central platform team. This balance between centralization and self-service helps the platform scale to thousands of active users inside the company while keeping operational overhead low. But this must have taken years to develop a culture like this, competency like this, infrastructure like this. This is such a cool thing to have though. Otherwise, there's surely a bottleneck, and this avoids that in big time. Breadth of event types. The platform currently handles around 1,800 different event types, each capturing different kinds of user interactions and system signals. There are dedicated teams responsible for maintaining the event delivery infrastructure, managing the client SDKs that developers use, building journey datasets which combine multiple event streams into structured, meaningful timelines, supporting the underlying infrastructure that keeps the system running smoothly. This massive, well-structured data collection layer forms the foundation of Spotify's entire data platform. Without it, the rest of the platform, processing, management, analytics, and experimentation would not be possible. It ensures that the right data is captured, secured, and made available at the right time for everything from recommendations to business decisions. Data management and data processing. Once data is collected, Spotify needs to transform it into something meaningful and trustworthy. This is where data processing and management came into play. At Spotify's scale, this is a massive and complex operation that must run reliably every hour of every day. Spotify runs more than 38,000 active data pipelines on a regular schedule. 38,000 active data pipelines on a regular schedule. Some run hourly, while others run daily, depending on the business need. A data pipeline is essentially an automated workflow that moves and transforms data from one place to another. 38,000, that's a lot, that's huge. But that's a lot. Because even managing one data pipeline could be a massive work. Decoding one data pipeline could be a massive work, and having 38,000 active data pipelines, that's so much. What if, say data, because they fail, and it's not the engineer's fault. Sometimes they just fail, and sometimes you just have to press refresh and rerun them to do that. And even just doing that for 1% of it, that's a lot. For example, a pipeline might take raw event data from user streams and aggregate it into daily summaries of how many times each song was played. Another pipeline might prepare datasets that support recommendation algorithms. Yet another might generate financial reports. Operating many pipelines requires a strong focus on scalability, handling growth efficiently, traceability, understanding where data comes from and how it changes, searchability, finding the right datasets quickly, and regulatory compliance, meeting privacy and data retention requirements. Data management and data processing. On the data management side, we have data management user experience and data processing, scheduling, and orchestration of pipelines. The execution stack. To run these pipelines, Spotify uses a scheduler that automatically triggers workflows at the right times. These workflows are executed on BigQuery. Google's cloud data warehouse allows fast analysis of very large data sets. I don't know what makes BigQuery so fast, but it's by far the fastest that I've used, by far, compared to things like Databricks. It's by far the fastest. Flink or Dataflow are frameworks for processing data streams or large batches of data in parallel. Most pipelines are written using Sio, a Scala library built on top of Apache Beam. Apache Beam is a framework that allows developers to write data processing jobs once and then run them on different underlying engines like Flink or Dataflow. This gives Spotify flexibility and helps standardize development across teams. Each pipeline in Spotify's platform produces a data endpoint. An endpoint is essentially the final dataset that other teams and systems can use. These endpoints are treated like products with well-defined characteristics. Explicit schemas so everyone knows exactly what data is included and in what format. Multi-partitioning to organize data efficiently, often by time or other logical dimensions. Retention policies specify how long the data is stored. Access control lists are used to define who can view or modify the data. Lineage tracking that records where the data came from and what transformations were applied. Quality checks to catch errors early and ensure the data is trustworthy. Platform as code. Spotify has built the platform in a way that allows engineers to define their pipelines and endpoints as code. This means all configuration and resource definitions are stored in the same place as the pipeline source code. As mentioned, the system uses custom Kubernetes operators to manage this. When developers push updates to their code repositories, the operators automatically deploy the necessary resources. This code ownership model ensures that the team responsible for a pipeline also controls its configuration and lifecycle, reducing dependency on centralized teams. With tens of thousands of pipelines, keeping everything healthy and efficient is a major priority. Spotify has a strong operations and observability layer that includes alerts for late pipelines, long-running jobs or failures, endpoint health monitoring to make sure datasets are fresh and accurate. Backstage integration to provide a single interface where teams can view and manage their data resources. Backstage is an internal developer portal that Spotify open sourced. It brings together tools for monitoring, cost analysis, quality assurance, and documentation. Instead of searching across many systems, engineers can manage everything from one central place. Conclusion: Spotify's data platform is a great example of how a company can evolve its infrastructure to meet growing business and technical demands. What began as a small team managing an on-premise Hadoop cluster had grown into a platform run by more than 100 engineers operating entirely on Google Cloud. So it's operating entirely on Google Cloud. I guess I wonder why not AWS, or I know Google BigQuery is used because it's fast, but I'm sure there are solutions like that through AWS or Azure, or maybe it's just a choice. This transformation did not happen overnight. Spotify aligned its organizational need with its technical investments, defined clear goals, and built strong feedback channels with its internal users. By starting small, iterating, and learning from each stage of growth, they created a platform that balances centralized infrastructure with self-service capabilities for product teams. Other organizations can take valuable lessons from this journey. A dedicated data platform becomes essential when teams need searchable and democratized data across business and engineering functions. Financial reporting and operational metrics require predictable, reportable pipelines. Data quality and trust are critical for decision making. Experimentation and development need efficient workflows with strong tooling. Machine learning initiatives depend on well-organized and structured datasets. That's a lot of information to digest. But it's really cool to get an insight into how a giant like Spotify functions and have their data platform set up. It's really impressive, and I'm sure that when we get down into details, there's so much more to learn. But yeah, I hope you guys enjoyed this too. Let me know down in the comments if you did. Thank you guys for watching. I'll see you in the next one. Like and subscribe. Bye.